We've all seen those images, right? These massive chunks of ice just breaking off glaciers, and all the headlines about the melting poles. Now, our first thought is almost always about sea levels rising. And look, that's a huge, huge part of the story. But it's not the whole story. The reality is actually way more complex and honestly a lot more surprising.
It sounds completely backward, doesn't it? A warming planet is somehow going to cause a regional deep freeze? To really get how this could happen, we've got to look deep beneath the waves, at this massive engine that powers so much of our global climate.
So, you need to stop thinking of the world's oceans as just these big, static pools of water. They're not. They're a single, really dynamic system with this incredibly powerful circulatory network. You can think of it like a giant global heat conveyor.
Okay, the scientific name for this whole thing is thermohaline circulation. I know, it's a bit of a mouthful. But the name actually tells you exactly how it works. You've got thermo for temperature and haline for salt content. And those two things, temperature and salt, are the twin engines driving this enormous current.
So here's how it works in a nutshell. You have this warm, salty water from the tropics, and it flows north along the surface, kind of like a radiator, releasing heat and warming up places like Western Europe. As it travels north, it cools down, gets even saltier, and that makes it dense. Now that density, that's the key. It causes the water to sink, plunging deep into the ocean, and then it starts its long, slow journey back south, completing this massive global loop.
So we've got this beautifully balanced, finely tuned engine. But what happens when you throw a giant wrench into the works? Well, in this case, that wrench isn't made of steel. It's made of fresh water.
As climate change just keeps accelerating, the melting of Arctic ice and the Greenland ice sheet is dumping a truly enormous volume of fresh water into the ocean. And it's happening in the exact spot where that critical sinking action is supposed to take place.
This really gets to the heart of the problem. It's basic physics, right? Salt water is dense, so it sinks. But fresh water is less dense. It's buoyant. It wants to stay on top.
So what happens is this flood of meltwater basically creates a lid right on the surface of the North Atlantic. It dilutes the saltiness of the water up there, making it less dense and stopping it from sinking. The engine just seizes up. The whole conveyor belt grinds to a halt.
And this brings us right back to that crazy paradox from the beginning. If you shut down the system that's responsible for bringing all that heat north, well, the consequences are pretty immediate, and they are dramatic.
I mean, think about it for a second. That current is like a massive hot water pipe for the North Atlantic. So what happens when you turn off the heat?
The impact could be staggering. Scientists estimate that a complete stop could cause a potential drop in the average temperature across Europe of 5 to 10 degrees Celsius. That is a massive climate-altering shift that would mean severely, severely colder winters. And here's the kicker. This isn't just some far-off computer simulation or a sci-fi plot. Our planet has actually done this before. This isn't just a theory. It's a known vulnerability in our climate system.
Yeah, about 12,700 years ago, right at the end of the last ice age, a very similar event happened. A huge pulse of meltwater flooded the North Atlantic. It shut down the conveyor, and it plunged the whole region right back into near glacial conditions. This period is known as the Younger Dryas, and it's a really stark reminder of just how fast this system can flip.
Okay, so that's the story in the Arctic. But this is where things get even more fascinating. If we fly all the way to the other side of the planet, down to the South Pole, melting ice there is triggering a completely different and, in some ways, opposite chain reaction.
So down south, instead of mainly messing with the deep ocean, the Antarctic meltwater's biggest impact is actually being felt way up high in the atmosphere. It's a totally different mechanism with a completely different set of consequences.
The contrast between the two poles is just wild. In the Arctic, meltwater weakens the ocean circulation, but down in the Antarctic, it changes the atmospheric circulation. Get this, the cooling surface water there actually leads to an expansion of sea ice. This cools the air layer right above it, but then the layer higher up in the stratosphere actually warms. It's this bizarre vertical split in the atmosphere. And this atmospheric response has some genuinely shocking ripple effects. A weaker polar vortex, for example, could actually help reduce the severity of the ozone hole. And listen to this, some models suggest these changes could slightly reduce the overall rate of global warming and even potentially delay the very weakening of the Atlantic current we were just talking about. It's a planetary scale feedback loop that scientists are really just starting to get their heads around.
So, what does all this mean when you put it together? It means our planet's climate system is so much more interconnected and, honestly, way more full of surprises than we often imagine.
There's this great quote from Tore Hatterman, a researcher at the IC3 Polar Research Hub, that just nails it. He says the findings remind us that melting Antarctic ice won't just raise sea level. It's also going to change the atmosphere and weather systems far, far beyond the Southern Ocean.
So here's the bottom line. The crucial point is this. Melting ice is not a simple one-to-one problem. It's not just about turning up a thermostat and watching the water rise. It's more like pulling on a single thread that can start to unravel these incredibly complex systems in ways we never expected, from ocean currents all the way up to atmospheric chemistry.
And it leaves you with a pretty profound question, doesn't it? We've managed to uncover these incredible, totally counterintuitive connections at the poles. But as we continue to push the boundaries of our planet's climate, you just have to wonder, what other surprises are built into the system, just waiting for the right trigger?